Hi everyone, welcome to another Leetcode problem. Today we're going to be doing number 70, which is climbing stairs. So here's the problem. We're climbing a staircase and it takes n steps to reach the top. So the staircase has n steps. Each time we're on a step, we can either climb up by one step or two steps. And it's asking how many different ways are there to climb to the top. So just to recap, we have a staircase here and we can either go one step or two steps from any stair that we're on. And we need to reach the top. So we got to count how many distinct different ways there are to reach the top. So let's try to break this down. Okay, let this white box be the single step and let the word top signify the top of the staircase. So we're trying to get from the staircase to the top. So how many different ways are there to get from one step to the top? Well, there's only one way really. I mean, you can't go above the top, so you can't take two steps there. So there's only one way. So from one step to the top, there's one way. And you can see in the code to the right, that's a base case of ours. So if n equals 1, meaning if we only have one stair, we return 1. There's only one way to get to the top. Okay, let's go to the next slide then. So let's say that we have two staircases now. So n equals 2. How many different ways are there to go to the top? So one way is to just take two single steps up to the top. But the only other way is to take one big step over two staircases and reach the top. So here we have two distinct ways to reach the top. So we'll put a 2 there. And if you can see in the highlighted portion of the code, we have n equals 2. If n equals 2, then we return 2, because that's another base case. Now, one step and two steps are our base cases because we can only move one step up or two steps up. From then on, that's all our base cases. So we would need to figure out if n is greater than those two, how can we calculate the distinct ways to go to the top? So let's make n equals 3 then. Okay, so in the highlighted portion of the code, you can see that I just initialized an array. The array could be represented as these white boxes or the stairs. And the array minus 1 equals 1 and array minus 2 equals 2. Those are just my base cases. I could do something where I initialize the array, set those base cases, and then if n equals 1 or n equals 2, return that spot in the array. But yeah, it's really just however you want to code it. So here, if n equals 3, then let's count how many different ways there are to get from the third step to the top. Let's just count them. So one thing we could do is take just each individual step up to the top, and that would be one way. A second way would be to take a small step and then one big step and reach the top. So that's our second way. Finally, we can actually start with the big step and then the small step to the top. So then we have 3 ways to reach the top if n equals 3. So that's 3 distinct ways to reach the top from the third step down. Okay, so it might be a bit hard to see the pattern here because we just have a simple 1, 2, 3 from left to right, or from right to left. But let's think about this. From step 3, we can move on to step 2, and from there's 2 distinct ways to go to the top. Or we can move from step 3 to step 1, where there's only one way. So you could think of this as adding the different ways to get from one step above you plus the different ways to get 2 steps above you. Because basically what you're doing from that step is you're combining the different ways to get to the top from the step above you and the 2 steps above you. So if we look at it, I mean 2 plus 1 just equals 3. So that would check out. Okay, so let's say that our n equals 4 now. How would we calculate this? So now it's really too hard to draw out the arrows and count it. So let's see if our algorithm would work. Okay, so we would take 3 plus 2. We take 1 step above us and 2 steps above us. Those are the only 2 steps accessible for us from the 4th step. And we add them. And we can see that there should be 5 distinct ways from 4 steps down to get to the top. Okay, so let's see this algorithm in action and maybe look at the code a little bit. Okay, so now we have 8 steps represented as this array, which is indexed at 0. And on the right, we have the code where we're going to be starting in this for loop. Now, in the actual solution, this is the full solution, by the way, if you guys want to just take that and submit it. But I'll step through how this works. So this solution starts from the third step from the top, or in this case, step indexed at 5. You can see that by the starting point of the range as n minus 3, for I in range n minus 3. So we start at step 5, which is the third from the top, and we would keep calculating. Now, since we already did that in the above slides, I'm actually going to start at step 3, but we'll see how this works. So we start in our array, and then we have the array at that spot be the sum of the value at the array 1 step above plus the value of the array 2 steps above. So for step 3, we would add together 5 plus 3 and get 8. So now we have 8. Then we would loop backwards in the array and move to the third step indexed at 2. And we would do the same thing. We would add 8 plus 5, and we would get 13. Okay, then we'd loop again backwards into the array. Now we're on step indexed at 1, and we would add the first two numbers from there as well. So 13 plus 8 is 21. So now 21 goes over here. Keep in mind, so we're adding the 2 steps in front of us because those 2 step values indicate how many different ways there are from both of those respective steps. So now we go to the final step, which is 0. So we loop the array back to 0, and we add the first 2 steps in front of 0. So 21 plus 13 is 34. So then we got 34 in the 0th spot. Okay, now that we've exited the loop, we've gone through the whole array, we would return the value of the array at the 0th index, or in this case, 34. So if n equals 8, then there would be 34 distinct ways to reach the top from the bottom. And so yeah, this is how the algorithm works, and you don't need to use an array. You could just use 2 integer values and keep track of the last 2 and keep adding them. I only initialized an array just to make this animation flow better. But yeah, let's see how it does in Leetcode. Okay, so here we have the solution in Leetcode, and if we submit it, hopefully we can pass all the test cases. And there we go. All right, so thank you guys so much for watching. Please let me know what problems you want me to do in the future. If you guys like the animations, let me know. If you guys prefer me to just keep drawing on my iPad, let me know. I really want to help as many people as possible with these animations. Maybe try to get, try to help teach you guys in a bit better of a way than just reading solutions on an online forum. So yeah, please let me know how I can improve these videos, and I'll see you in the next one. Thanks, guys.